Nice. Awesome. So just to introduce myself, my name is Jorge Peruzio. I'm a software developer at IBM. So I've been working with Hyperledger Fabric for the past year and a half, and one of the really cool client projects I worked on was deploying a composer solution that was leveraging Fabric to track coffee and use that and track the supply chain of coffee. And that had about, I think it was about 650 transactions there, and we deployed it on a one-day event, so that was pretty fun. So I want to talk to you a little bit about both kind of my experience building applications with Hyperledger Fabric and some of the best practices and designs that you can take. And hopefully everybody of all levels, whether you haven't heard of blockchain or you're advanced, hopefully you can take something out of it. And then just a little bit about me. I was a computer science major at UC San Diego, and then started working at IBM after. So just to learn a little bit about you, how many of you understand how a blockchain works? More or less, at least the key concepts. Okay. What about Hyperledger Fabric? Who kind of knows the key concepts behind Hyperledger Fabric here? Okay. I was expecting more there. How about who's actually developed a smart contract, whether that's Hyperledger Fabric, Ethereum, other smart contracts? Okay, a few. What about developed a decentralized application? So both front end, also smart contracts, 1%. And then deployed a network to production, anyone? Got one person. Okay, cool. So I think this should be pretty good material here. Should be enough introductory material to understand, and then also have a little bit more advanced material as well. So the way I'll kind of break this up is the first half will be slides and concepts, and then the second half will kind of implement and show how to implement a lot of the concepts. And I'll show kind of a live coding demo, and we'll talk more about that. So just to kind of so we're all on the same page in terms of what we'll learn today. The first thing is we'll talk about vocabulary. So I want you to be able to have a conversation with someone about blockchain. So both, not only Hyperledger Fabric, but other blockchains as well. What's the difference between public and private, et cetera. We'll also talk about a use case of blockchain, the architecture behind a Hyperledger Fabric solutions. So what components are required for this type of solution. Another key concept we'll talk about is the difference between the Worldstate and the ledger. So I won't get too deep into that now. Public and private. And then the last is how a client application invokes a smart contract, and that's going to be more or less the primary focus. But we do need to kind of get through that introductory material before we get to how a client application invokes a smart contract. So let's start off with public versus private. So here I'll start talking about public networks. So the first kind of implementation of blockchain that really kind of got blockchain onto the scene was Bitcoin. And I kind of want to contrast public versus private here as well. One of the key components is how you manage users in a public network versus a private network, and that is that in a public network, all these users are treated equally. There's no special control for each user. Whereas in a private network, you can have different sets of rules for these participants. Identity is also anonymous in a public network, so that's also something you have to keep in mind. In a private network, so whether that's Hyperledger Fabric, Quorum, or other private networks, the members are known, and you can keep these transactions secret, and you can have different access control rules for different participants. So I think what it really boils down to, whether you want to implement a private or a public network, is how you want to manage identity. So do you want, does your use case need anonymity, or does your use case need enable or make you have to know the participants? So I think there's plenty of room for both public and private. I'm going to focus on the private blockchain today, but I think that in an overall solution, you can easily implement both, and you can have a little bit of both depending on what you need. So I think for businesses, especially in a KYC where you need to know your customer, then a private network does make sense. And then where you want to have all these users treated equally, then maybe you want to have a public network there. So now I'm going to talk a little bit about the difference between the blockchain itself and the world state. So usually in a ledger, we think of these two different data structures. Blockchain is the immutable one, and that's kind of what everyone thinks about when they think of a blockchain. And this is the linked list of blocks, this append only. and this is the way that you are able to audit and verify everything that's happened on this network since the Genesis block. And this is immutable. And the difference between the world state and the blockchain is that the world state is the current moment in time of what the network looks like. So, for example, if we start with nothing on the network, the world state is going to have nothing. In the example that we'll show later, we're going to add voters to a network, and then each time we register a voter, the world state will be updated, and then the blockchain will be updated as well. And then we can take voters off the network too. That will be reflected in the blockchain as well. The key difference here is that you can delete off the world state, but that will be recorded in the list of transactions, of course. And this world state is a database that's running on each peer of the network. And each peer is going to have this database synchronized. So everybody's going to have the same contents in the world state, especially as we go through consensus. Yeah, so essentially the world state is the key value store. And we'll kind of see how that's implemented in the second half of the presentation. To talk a little bit more about the blockchain itself, so not the world state, but the blockchain, this is kind of a simplified version of it where you have each block, and each block contains a hash of all the transactions inside of that block itself, and it also contains a pointer to the previous block hash. If you try to, let's say right now we're at block 17, let's say if you go ahead and change the content in block 15, that's going to invalidate block 16 and 17, so you're gonna see that something has been tampered with, and the hashes will not correspond or will not agree anymore. So that's how this list of transaction works. You have the hash of the current transactions and then the hash of the previous content, the hash of the previous block's content. New blocks are always added to the end. That's what makes it append only. And that's kind of more or less it for the details of what's inside of a block. Now we'll talk a little bit more about Hyperledger Fabric. Hyperledger Fabric is an open source solution, and it's a platform for distributed ledgers. So it has contributions from hundreds of engineers from tens of organizations. IBM is a pretty big contributor there, but there's plenty of other organizations contributing as well. Within the Hyperledger ecosystem, there's plenty of projects outside of Hyperledger Fabric. So there's Hyperledger Indy, that's focused on user identity. There's Burrow, which is focused on implementing Ethereum smart contracts and running them within Hyperledger. So there's plenty of other projects, but the key thing, it is open source, so everything's available online. Some of the features of Hyperledger Fabric is that it has smart contracts to be able to update the ledger. We have our consensus policies, which is different than a public network, and I'll get a little bit into that as we go on. And then we have a way to add privacy to the network. So that's, of course, different than our public network. So we have different mechanisms, whether that's private data, whether that's channels, to actually create privacy into the network. So in terms of the actors in blockchain solution, I'm going to be focusing mostly on the blockchain developer. So I want to talk about how to build smart contracts in the client application, but we'll also see the view of the blockchain user. So this is just whoever's using the application. They don't need to know anything about blockchain. They're just using the application itself. And then we'll see a little bit of what the blockchain architect will think about as well. So again, the blockchain developer is focused on the application and the smart contracts and how they interact with the ledger and other systems of record. The smart contract itself is something that's going to be installed on all of the different nodes in the network, and then we want to be able to update the ledger and to ensure that we create value for whatever use case we're trying to solve. So I'm going to talk in terms of the components. I'm going to kind of run through the components here. So the ledger itself is the list of transactions maintained by the peer that has the world state as well. The smart contract, that's the software that's running on the peer, and it updates the world state, and it's able to, that's kind of that layer between the application and then the blockchain itself. Then we have the peer network. So these are the actual hardware, so whether that's deployed as Kubernetes, which is currently how we have it here. You could also use Docker as well. But this is the network of nodes that is actually going to reach consensus or try to reach consensus to update the world state. And only if we reach agreement, only if we reach agreement on this next transaction will it actually be added. And we'll talk a little bit more about that too. So membership is also very important. As we talked a bit before, public networks, anyone can join. In a private network, identity management is extremely important because in a lot of networks, you want to have different rules for different participants. So being able to figure out which participant is which, are they able to read, do they have read access, do they have write access, which parts of the network are they able to read, that's very important. And that's also done by membership. And in terms of Fabric, Fabric has a certificate authority that creates public and private keys, and we'll see that in action here in the demo. And that's kind of, in Fabric, that's what's, the certificate authority is what's managing these credentials and what's managing the identity on the network. Events are notifications of operations on the network. That's nothing special with blockchain. Systems management, that's enabling us to create and monitor blockchain components. So in terms of kind of the tools that I use, I mostly use there's a IBM Blockchain VS Code extension, and that enables you to spin up a local Hyperledger Fabric network with the push of a button, which is really nice. And that creates 4 Docker containers, and you're able to deploy your smart contract, test it, package it, and that's really, really nice. So in our example later, I'll show you a network that's deployed on the cloud. But before I deployed it there, I've tested it and made sure everything works on my local machine. The wallet it manages the user's credentials, so we'll see the public and private keys there. And the last thing we'll talk about is systems integration. So a lot of people I've talked to today will ask me, do I have to create a whole new application for blockchain? And the answer I usually give is that no, you can usually use whatever application is already running in your business and send some of the critical data that you need saved and you want to be able to be audited later. You can send some of that data to the network. So you don't have to create a brand new application. You can just integrate whatever part of your application that you see critical with this blockchain network. So smart contracts contain the business logic. When people think of programming for blockchain, they think of smart contracts. I think that that's maybe less than 50% of the work. A big part of the work is the client application and how you're actually submitting transactions and actually reaching consensus. So there's a lot more to developing blockchain solutions than just smart contracts, but usually that's what people think of when they're developing. And the way that they update the ledger is that they interact with the world state. And we'll see some of the APIs that are needed to update and to change the world state. In terms of Hyperledger Fabric, this is also something that's really important, is that we have language support in terms of our SDK for Golang, for Node, and for Java. This is definitely different than Ethereum, which has its own special smart contract language. And kind of what you need to keep in mind is that these languages were not built for creating smart contracts, but Solidity was. So Solidity might have some more features that enable it to have more secure smart contracts, or it kind of keeps it takes into consideration that you're building a smart contract. The good thing about Node.js is that you don't have to learn a new language, or Java or Golang. You don't have to learn a new language to implement a smart contract. You can use whatever you already know, and you just use this SDK to actually update the ledger. So what we usually have is we have some sort of administrator that installs and instantiates the smart contract on the peer. And usually there's multiple peers in a production solution. You don't want one peer because then there would be no way to reach consensus if you only have one peer. So you would repeat this process for all the peers. So you'd install and instantiate the smart contract. And then the client application is going to, whatever data you want to send to it, you'll send some data to the peer, and then that will invoke the smart contract. And we'll see kind of that in action as well. So again, the client application uses the SDK, and it keeps the wallet as well. So the client application needs to be able to sign each transaction. So before we actually submit a transaction, we have to have an identity to actually sign that transaction with. So the first thing we do, and we'll see that later, is we create identities. We create a public and private key for all of these participants so that each time they submit a transaction, they can sign it with their private key. And then if we need to audit, we're able to pinpoint each transaction to a specific member on the network. Another thing that it does is that it looks for the ports. So if we're running Kubernetes, which the example we are, it'll look for where exactly this node is hosted, and it'll connect to this node. And that's what this client application does. It finds all the peers on the network, and it sends these transactions to the peers that need to validate and that need to reach consensus. And then the connection profile, that's where you have all the network addresses of the Kubernetes components. And then, yeah, so that's essentially what I talked about earlier. And now, this is kind of like the whole, I don't know, what you would do as a blockchain developer in a nutshell. So in a nutshell, you would develop this client application. So you'll have some sort of front end. You'll have this SDK that's talking to the smart contract, and then the smart contract is actually going to be updating the world state, and then each time the world state is updated, that will be logged into the blockchain as well. And then once that's logged into the blockchain, you'll have an event emitted, and then the app will respond. And then we have get, put, delete. So again, we can delete stuff from the world state, but each deletion will, of course, be recorded onto the blockchain network for auditability. Yeah, go ahead.
What is the use of Worldstate? I don't.
So the use of the world state is that so let me repeat the question. What is the use of the world state? So the world state keeps a snapshot of the blockchain at each point in time. So if you start from block 0 and go all the way to the current, so if we're on block 17, if you take every single update that's happened in the blockchain and you apply it to the world state from the beginning, you'll reach the current state. So it's basically the database that is connected to each peer. So now I'm going to talk a little bit about a sample use case. So if anybody is seen in the news, I think West Virginia is the first state that's going to be running a e-voting application that's running on a blockchain network. So I think that's going to be in production, I believe, this year. And in my use case, I want to talk about how we would go about creating something like this. So this is not going to be a fully production-ready application, but it'll be kind of enough to get you started and get you on the right path. So in an e-voting blockchain solution, I want to talk about how all these network components that we talked about earlier, how would they fit in this use case? So in terms of an e-voting application, for the ledger, we're going to have the history of the submitted votes and the history of every voter that has been registered, or if someone is revoked, maybe, I don't know, this person left the country, they're not a citizen anymore, we'll have a history of that voter being revoked as well. Smart contracts, so our smart contract in this use case will be called voter contract, and what the main functionalities it does is it registers voters and it submits votes, and then it also tallies these votes. The peer network, so in this network, these are the peers that are going to agree that this vote is valid and that this vote should be added to the network. Same thing with registering a voter. In our peer network, all these peers must agree that this voter is a citizen and has passed all the requirements to be a registered voter in whatever state that they are in. The membership here, so when we register for a voter, once we actually successfully register this voter, we create a public and private key for each voter. And that's what the Fabric Certificate Authority is going to do here. In terms of events, so whenever you submit a vote, we'll get an event. Whenever you register a voter, we'll get an event. If there's some sort of error, we'll get an event as well. So for example, we'll see if you try to vote twice, you'll see, look, this person has already voted, or if somehow you're trying to use a voter ID that's not registered, so the application will say, look, this person isn't registered to vote. Systems management, I talked a little bit about this. This is a good way, VS Code extension is a good way to manage the nodes in the network. I'll also show you a small preview of the IBM Blockchain Platform. That's how I manage these nodes as well. The wallet will store our voters' public and private keys, and each time a voter submits a vote, they'll use that private key to submit their transaction. And so another way to enhance my application would be to have another API or some way to validate voter registration. So if there's a way to talk to the DMV database, whether that's to validate if this person has a driver's license in the state, or if there's other identity solutions that we could use here to actually validate that this voter is a citizen and that they pass all the criteria to be able to be registered to vote, this is where we would integrate other systems into our application. So this is the app architecture that we'll see. So we'll kind of go from the front end, from the right-hand side. So we'll be the user. We're talking to a Vue.js web client that's running an Express server in the back end, and that's talking to the IBM Blockchain Platform. If you want to run this app locally, you can do that too, and that you can just use your local Docker containers to do that. You spin up a Hyperledger Fabric network locally, and then install the smart contract there, and you can run it that way too. So a quick example of kind of the code that we're going to be seeing. So now I've talked to you a little bit about what kind of our use case is. We've talked about an e-voting application. And now I want to show you kind of an example of what the code would look like to submit a transaction. So from our client application, we're going to send an invoke. And what invoke takes in is it looks for a specific contract. In our case, it's voter contract. It looks for a function. So each smart contract can have multiple functions inside of it. My contract, the main two functions we'll worry about is register voter and cast vote. So for this specific, invocation, we'll do cast vote, and cast vote takes in 3 parameters. It takes in the election, it takes in a voter ID, and it takes in what political party you want to vote for. Yeah?
Isn't voting the very idea that you have a centralized voters registry run by the state, and it's a single point of trust?
So the question was, isn't voting an application where you want a centralized point of trust? Is that more or less it? Yeah. So I think the the reason why someone would want to have a voting application on the blockchain is to ensure that that I'm able to check that my vote has been registered. So right now in the current political system, there's not really a good way to be able to ensure that my vote has actually been registered. And then also to be able to have this audit log of, exactly how many people have voted. So there will be parts in the network, like there has to be an external source, whether that's the U.S. government, the Department of Motor Vehicles, someone that has to approve these, right? And there will be these other participants, but you still will have this extra auditability and security added to it. So essentially, we'll send in this vote. We pass in the election. We pass in the voter ID. We pass in what political party we want to vote for. You'll probably want to keep that anonymous, but for here, I'm just going to show you because it's easier to show you. In terms of the implementation, we'll go into cast vote, and then more or less, we're just going to increment the count for the Democrats if we're voting for that party. And then the world state is going to, if this is the first vote in the world state, the count of the Democrat will be 1, and then this voter ID will have a flag that said that they've already cast their ballot, so they can't vote anymore. So you can see in the world state on the left, the Democrat count is 1 now. And then within the actual list of transactions, we can see, look, we invoked this smart contract called voter contract. We called this function, and we passed in all these parameters. So that's what's going to be logged into the list of transactions. OK, so now let's go into the demo. So let me make sure everything is OK. So here's our demo. So we have this front end here, and essentially the 2 main functions we're going to call again is register voter and cast vote. So right now at the bottom we're going to register to vote. I'm not going to put in a real driver's license right now, but does someone have a fake driver's license they want to give me to make sure that the demo is going? What?
1, 2, 3, 4, 5, 6, 7, 8, 9.
1, 2, 3, 4, 5, 6, 7, 8, 9. OK, that works. I'll say Portland, and then I'll just say Bob Dylan. So let's see so now we're going to register to vote. So now we can see at the bottom, this voter ID is updated in the world state. We can use the voter ID to log in above. So at this point, we've emitted an event, we've invoked our smart contract, and we've registered this transaction on the network. I'm not going to show you that this second, but we'll go back and look at all the transactions we've done. So now I can use this voter ID to log in, but I'll just show you, like, if I use a fake voter ID to log in, it's not going to work. So I'm just going to add an A at the end. So you can see that now. This should not work. So we'll say error, this doesn't exist in the wallet. So each time we actually register this user, we create a public and private key for that person. So if we look in our actual wallet here, we should be able to see 1, 2, 3, 4, 5, 6. So server, So yeah, so we should see it on we should be able to see it right here. Where is it? So yeah, we'll be able to see it. Oh yeah, here we go. So here's this is the user we just enrolled, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now let's go ahead and log in with that name. So we should be able to log in now. So now we can go ahead and cast a ballot. Does anybody have a specific political party they want to vote for? Okay, so we're going to go Republican. So again, I'll show the same kind of example. If we add an A or something like that at the end, they should not let us vote. So just say, make sure you're entering a valid voter ID. Now we're going to go ahead and do a normal vote. So this should work. So we've successfully recorded the vote. So now if we try to vote for a different party, let's say with that same voter ID, let's say we try to vote for the Green Party. It should not let us. So it'll just say, OK, this voter's already cast a ballot. You can't vote. So now we can kind of go ahead and query and see what the poll standings look like. So the Republican just got another vote. So I was testing this a little bit before, but that basically incremented the Republican's vote. And just to make sure, I'll just do a quick 1A, B, C, D. I'm just going to show you a quick vote to show that the Republican goes to 3. So we'll log in again and cast the vote for the Republican again. And then we should be able to see that the poll standings are at 3 here. OK, cool. So now let me show you kind of the code that's going on in the back end. So first, I want to talk a little bit about the smart contract. So again, this is the cast vote. And the cast vote takes in 3 parameters. It takes an election ID, it takes in a voter ID, and a votable ID. The votable ID is the political party. So we have this function. So when we go into so when we're in that cast ballot page, that's when we actually are putting in these. That's where we actually select the party. So essentially what we do is, this is the political party that we have, or this is our votable ID. We want to make sure that there's an election to vote for. That's all done in the back end. If the election exists, we want to make sure that the voter exists, right? And we want to check if this voter has already cast a ballot. So that's the error checking we saw earlier. Then we want to make sure that the election is currently open. So we just do some error checking to make sure that if the election, like for example, the election day in 2020 is November 3rd, we want to make sure that you can only vote within that 24-hour period. So you want to check if you're currently within that time range. Then we're going to check if this political party exists. So if it somehow you picked something that isn't allowed to be on the ballot or something like that, we'll say like it doesn't exist. And then the last thing is just we increment. If it passes all the checks, we actually increment that political party's vote count. And then we just save that information. And then the put state is what actually updates the state. And that's actually talking to Hyperledger to the Hyperledger Fabric SDK. So sorry, that's going to actually update the world state. So now let's go a little bit backwards. So now we're going to start from the front end and then go all the way back to the smart contract. So again, what we're doing is from the front end, we have some sort of inputs, we have some sort of values, we send that to the client application. That client application is running the Hyperledger Fabric SDK, and that SDK sends that transaction to the smart contract. So we just saw the smart contract. Now let's go ahead and see the front end. So from the front end side of it, we have our cast ballot. So we have at the front or at the top, we have all of our political parties. And then we have, once we submit something, it'll go into this cast ballot function. So where's the cast ballot? There it is. So in the cast ballot, we're just making sure we have an election already running. This is just checking just some front end checks to make sure that they actually picked a party. Yeah, and again, you have to enter in a voter ID to actually vote. And then it goes into this cast ballot from our API service. That is going to be right here. So in our cast ballot, this is essentially our bridge from our front end to the back end. So now we're running an Express app. So this cast ballot will look for the a cast ballot endpoint. So let's go ahead and find that. So in our app.js, we should see a cast ballot. So here it is. So now we're in our Node.js server. So this is going to be talking to the client application. So the client application is this network file. And the first thing we have to do is actually connect to the network. So that's actually ensuring that this voter exists. So we look in the world state, does this public and private key actually exist? So let's go ahead and check out the network function. So in this, here it is. So yeah, in the connect network function, we check for the wallet and make sure that this username exists. If this username doesn't exist, we have to register an identity for them. After that, we connect to the network, and we're connecting to the network by passing in our wallet. The name so the wallet contains all the identities, but then we want to pass in a specific identity. So that's when we're actually putting that voter ID, we're passing in our identity there. And then we have a specific voter contract. So we're looking for this specific contract, and in our actually contract directory is where we actually create this, and it's in our package JSON is where we actually call it. So this is the name of the contract. If we want to export the contract, this is how we would do it with the package.json, and we can see the version here as well. And so let's go back to the network file. So after we've actually connected the network, we want to invoke something. So we'll go to this invoke function, and in our actual cast ballot, let's see, in our actual app here. So after we've connected the network, we go ahead and call invoke. And this is where we pass in the network object. The network object is going to contain the actual smart contract, whatever channel it's running on, and it'll say, we're going to invoke this function, which is cast vote, and we'll pass in the args there. And then, so this server, or this Express server, will talk to the client application. So this is the client application, and we'll talk to invoke. And then this is where we actually submit the transaction. So this contract.submit transaction, this is what's actually talking to the world state and actually sending these transactions to the peers. And then the last thing that I want to cover is this connection profile. So this is what's actually talking to the different Kubernetes components. So each time you create a new peer node, you'll have a new node within Kubernetes, and you'll want to add this to the connection profile so that you can send this transaction to each peer. We have the certificate authority here as well, and we can see that all within our actual platform here. So if we look at our certificate authority in the settings, this should be that same URL. Okay. And then, okay, so now let's go ahead and check out the actual list of transactions. So in our My Channel, we're able to see all the different transactions that we've submitted. So if we submit a transaction and it doesn't reach consensus and it doesn't actually get approved, we'll see that someone tried to submit a transaction, but it didn't actually update the ledger. So we'll be able to see that, I think, if it doesn't have an output. So this one does have an output. So let me show you one like that. Yeah. So let's see. Yeah, so this is the cast vote that we did earlier. So this is when we picked the Republican Party. So you can see the voter ID right there. We picked the Republican Party. And we have all this information here. So this right is actually updating the world state. And it's all key value pairs. So the key being the voter ID and the value being that they picked this specific political party. And then we're also incrementing this specific party's count. So that's just how many votes they have. And so in block 26, we should see that we actually registered the voter. So that is right here. So again, this is calling the create voter function. And this is where we can see that we're writing this specific voter ID onto the network. And then we create the ballot for them. So this big unique ID is just all the choices they have to vote for. And essentially, what we've done is we've taken this smart contract that's running on where is it? Here. So this is on the left-hand side, we can see the blockchain platform extension. And what we've done is we have this, or is the voter contract? I have a lot of contracts in here. So you can see our voter contract. We've taken it from here, and we've installed it right here. And then that's how we've installed it on the network, and that's basically running on all the different peers. OK, so I think that's mostly it. Let me go back to the last couple of slides. So we've talked about the different vocabulary, right? So we've talked about both what is the client application, what does that do? What do the peers in the network do? So essentially if we want to actually build a consensus mechanism for this specific network, we'd want to be able to have separate organizations. So right now we have a voter organization. We want to have some sort of external, whether that's external organization, whether that's the US government, some sort of DMV, or some other participants. And then essentially we'd want to have multiple nodes. Oops, good. There you go. So you want to have these nodes. Essentially, you'd want to have more than 4 or 5, and then you'd want to have at least 50% of these approving these votes before it actually gets onto the ledger. So some of the architecture that we talked about, we've talked about the peer nodes that's actually running the smart contract. We've talked a little bit about the difference between the Worldstate and the ledger. Worldstate, you can delete things. The ledger is immutable, so you cannot delete that. And then the biggest difference between public and private is that identity management. So how do you want everybody to be anonymous? Do you want to know who you're dealing with? What use case, or how important is that for your actual use case? And then we talked about how the client application invokes a smart contract. So we have this SDK that's submitting transactions. So we have this UI taking some sort of data, sending it back to our whatever backend server we're using, and then that is actually going to use this Hyperledger Fabric SDK to submit transactions to the smart contract. And then the smart contract can be developed in a bunch of different languages. So here's any contact. So I have a YouTube channel with a lot of different Hyperledger tutorials if you're interested in learning more. Twitter, I'm somewhat active on that, but more active on YouTube. And then any sort of more technical questions or anything like that, you can email me. So that's pretty much it. Thanks so much for everyone for coming.
All right, we have time for exactly one question. So,
what would prevent some sort of bad actor from doubling the amount of nodes in the cluster and basically allowing the consensus for only what he wants?
So the way that whenever you create a channel, so when you're transacting on a network, you create a channel, and within that channel, everyone is transacting. That's where everyone is transacting. So when you create the channel, you have to say, look, when we update our endorsement policy or our consensus, how many members of the network need to approve it? So if you want to make it very secure, you'll say look, everyone has to approve when new nodes join, everyone has to approve the new consensus policy. So you're able to set that at the beginning of when you start the network. That you'll say look, everyone has to approve this when someone new is added on the network.
What would be an example of a consensus policy in this case?
So you can have it anywhere from every single node that's on the network needs to approve it before it gets added, or in a development case you can say, this doesn't make any sense, but you can say one node has to approve it, and that would mean that it's the fastest it's the fastest possible network you could have, but it would only be for development. So you can how fast your network runs is all it's dictated by how many nodes you have, what consensus policy you create.
I'm sorry, that's all the time we have for today. Thank you, Horea.
Okay.
Appreciate your time. One more big round of applause for Horea.